see, Puta, there's some kind of a small thing, okay? Maybe a ball or something that he had used. When the waves are coming, right, you will see that this particular object is not moving from here to here, but rather it causes it to move up and down only. Look at this here.
Per second approximately. Waves are all about energy transfer. Particles of the medium remain in place. I floated this small foam piece on water. With waves, it moves in place up and down, but does not move along with the wave.
Does this make sense, Puta, why it did not move, the boat did not move from here to here, but rather it moved up and down, right?
Yeah, miss.
Yeah. Okay, so that's something. I'll send you all of these
I could
things,
capture
okay?
another
Y'all, if y'all are interested, y'all can watch. There are multiple videos where they are explaining about the ripples, the calculations, and all sorts of those things. Right. So here we are at the second question. Let's discuss this and we can wrap things up. It is made to vibrate by a force applied to the end A, right? So you give it a nice slap, right? So what happens? It goes ding like that. Give a rough sketch to illustrate one vibration generated in the blade. So just one vibration, Puta. How would you draw? Let me come back to my paint screen also. Okay, so it would look something like the blade. Okay, and it's going to vibrate to one side. Isn't it, Puta? The blade. This is point B. This is point A. So it's going to vibrate to one side and then it's going to bounce back to the other side as well. So of course, I have to make it a point to make these angles the same, no? Isn't it? Do you all agree with that? Does that make sense, Puta? This is how it will vibrate, no? Do you all agree? It's going to bounce like this. Like how the in those big old clocks, the hickory dickory dock, that thing, it will swing like this, like that. Does this make sense?
Yeah, miss.
Okay, right. Okay, so it's going to move like that. Back to the textbook. Use the letter C and D to show the maximum displacement. Okay, so I'm going to mark here as C and here as D. So it's going to go back and forth, back and forth, back and forth. Right, but the maximum on this side is C, the maximum on this side is D. Okay, done. Describe what is meant by amplitude using the points marked as A, C and D. Okay, so what is the amplitude? Well, of course, පුතා මේක අපි මෙහෙම ඇන්දනම් let me show it to you all in the form of amplitude. The graph that they use in the textbook, පුතා. Amplitude එක කියන්නේ maximum distance එක නේද? Right? So if I were to draw this in a graph and show you all, this is how it's going to be. The point that it is not moving is A. Okay? A to C it comes. The maximum onto one side. Okay? Whoop, like that. Okay? And then what happens? It goes back. Movement 1. And then second movement from here to here again. Isn't it, Puta? That is the second movement. So it's going to come back to A again. Okay? Whoop, back to its initial position. And then what's going to happen? It's going to go to the other side. Movement 3. So it's going to go whoop, like that. And then it's going to come back to A. Again like that. Okay, so here is A to C, C to A again, A to D, D to A again. Does this make sense, Putta? This is one oscillation. One complete oscillation. Make sense?
Yeah, miss.
Okay. What about others, Putta? Shafka, මේක තේරුණාද පුතා? Raida?
Yeah. Yeah, miss.
All right. Okay. So then they ask you, okay, now that is the maximum, what do we tell? Maximum distance, no? So you have showed the amplitude in this graph also, isn't it? Right? So you can tell C is the maximum distance to one direction and D is the maximum distance to the other direction. So accordingly, we can draw a wave of such. Then you can draw and keep that. If 50 vibrations are taking place during 5 seconds, find the frequency vibration of that metal, right? So what is the equation, Putta? F equals 1 over T. So they gave you 50 vibrations are taking place in 5 seconds, right? So how do I do this? How do I write it, Putta? Frequency is equals to 1 over T, right? With this, I can come to a conclusion. What is the definition of frequency, Putta? What is the definition of frequency? Go back to your book.
Maximum displacement shown by the particles taking part in the wave motion.
No, Putta, I'm asking you the frequency's definition. The number of vibration per unit time, no? Yes, Putta?
Yes, sorry.
Yeah, the number of oscillations carried out by the particle in a unit time. So, ඔයාට කියනවා පුතා, the number of oscillations is 50 low. And then they are telling the time taken for the 50 is 5 seconds low. Right? So, කොහොමද පුතා අපි එක ලියන්නේ? 50 divided by 5, you get 10. So, vibrations doesn't have a unit, right? Vibrations doesn't have a unit. Time does have a unit, seconds, right? So, then you get 10s minus 1. Isn't it the unit for frequency? So, what does this mean, Buddha? 10 vibrations per 1 second. So, in other words, you can write it as 10 hertz. All of this should make sense to you, Buddha. Right? So, hertz. තේරුණාද? තේරුණ නැත්නම් අහන්න ඕනේ. Vibrations doesn't have a unit, no puta. Vibration කියන්නේ how many times it's going to move. 50 times, 100 times. The faster it moves, the bigger this number gets. So what is the time taken for it? 50 vibrations per 5 seconds are. So then 1 second per second, it's going to move 10 times. It's going to go like this. Like that. Like this. How many times? Within a second, it's going to move 10 times. So what does that mean? It has a frequency of 10 hertz. තේරුණාද?
Yeah, miss.
Okay.
Yeah, miss.
Right. Okay. If you all don't get it, I want you all to tell me, okay? Can you explain it again or I can't understand this part? Okay, you all have to tell me. Okay, last question. Okay, I'm going to stop from here. Okay, vibrations of the metals give rise to the compression. Okay, it's okay. We'll do this part in the next class, Putah, because this is something to do with sound waves and all. Right, till what we explained now, is there any questions, Putah?